Space is supposed to be predictable. A silent machine of gravity and light. Every orbit exact, every motion accounted for. But in November 2025, that rhythm broke. An object called 3 Atlas, no larger than a mountain, began to accelerate. No jets. No tail. No outgassing. Nothing visible to explain the force. At the same time, the sun erupted in violent flares that rattled Earth's magnetic field. The coincidence caught attention. Among those watching was geophysicist Stefan Burns. His words were blunt: a big wave is coming. 2 events. 1 moment. Coincidence or coordination? 3 Atlas was supposed to behave like a comet, sputtering, spinning, fading as it neared the sun. Instead, it moved with calm precision. No drift. No chaos. Its motion looked guided, as if some invisible pilot had taken control. Astronomers tracking it through NASA's Jet Propulsion Laboratory data saw what they couldn't explain. The numbers told of acceleration not powered by gravity alone. The force broke down into 3 components: A1, A2, A3 directions of thrust. A1, radial, was pushing toward or away from the sun. A2, tangential, ran along its path. A3, perpendicular to the orbital plane, was exactly 0. Not small. 0. That's not how comets behave. Natural outgassing produces thrust in all directions. Jets flare unevenly. The nucleus spins. Forces twist and wobble. Nature is messy. But 3 Atlas moved as if under programmed control, pushing only in 2 dimensions. For 20 days, its speed climbed by 60 meters per second, and telescopes saw nothing: no venting, no brightening, no visible tail. Its brightness stayed steady near magnitude 14.8, a fixed glow in the dark. Picture a boat gliding faster across a lake with no engine, no wake, no wind. That's what 3 Atlas looked like. If this was a comet, why did it move like a spacecraft? The data implied 2 paths: either an unknown natural mechanism or deliberate engineering. Both rewrite what we think the universe allows. At the same time, Earth's systems stirred. Burns warned that solar and seismic patterns were converging: the 28-day recurrence of coronal holes, the Tauride meteor stream, a supermoon, and planetary alignments. Solar flares were hammering the magnetosphere. Earth's crust was trembling in clusters. He spoke of an energy surge sweeping through the system. In the skies, an interstellar body was accelerating with unnatural precision. On Earth, magnetic storms flared. The timing was exact enough to raise suspicion. Coincidence is common, but in science, coincidence is often where discovery begins. Astronomers then focused on what made this case unique: that perfect 0 in the out-of-plane component. Normally, a comet's jets twist through all 3 axes. Thermal vents fire randomly as the surface turns. But 3 Atlas stayed flat. No vertical drift. To achieve that naturally, the nucleus would need perfect symmetry, vents positioned with surgical precision, rotation aligned so that every out-of-plane push cancels out. Possible in theory, but almost impossible in nature. Hypotheses began to stack up. Uniform venting across an evenly spinning surface. Exotic volatile ices like carbon monoxide or nitrogen that sublimate without dust. Microjets too faint to resolve. All could, in theory, produce thrust. None could explain the flat precision or the silence. A comet producing thrust without light or debris defies the expected chain. Thrust implies mass ejection implies visibility. Yet nothing was visible. Observers searched for a coma, for faint gas lines in spectra, none appeared. The object was inert, yet accelerating. That paradox pushed some to consider the unthinkable. A light sail. A thin, reflective sheet pushed by sunlight itself. Radiation pressure at 1 astronomical unit is small, but over days it accumulates. A sail of a few square kilometers, made of ultralight material, could produce the same acceleration. The force would align naturally in the orbital plane. No gas, no tail, no noise. Others proposed a controlled propulsion system, a spacecraft performing a deliberate burn. Small thrusts in one plane. No exhaust detected because the propellant was exotic, the exhaust invisible. That would make 3 Atlas not a wanderer, but a vessel. And then came the wild cards: electromagnetic forces, dark matter interactions, heliospheric currents, new physics at work. Each stretched credibility, yet none could be ruled out. The debate mirrored a memory from 2017 Oumuamua, the first known interstellar object, which also accelerated without visible venting. It was cigar-shaped, fast, silent. Some thought it a natural fragment. Others, a sail. Then came Borisov, another interstellar visitor that behaved exactly like a comet, restoring balance. Now 3 Atlas blurred the line again. Neither comet nor rock. Neither natural nor mechanical. 3 Atlas arrived during the solar cycle's fever. 2025 saw the Sun at maximum X-class flares, coronal mass ejections, and storms lighting the poles. The March 19 flare alone hurled plasma at Earth, compressing its magnetosphere and sending auroras to southern Europe. Power grids shuddered. Satellites dodged radiation. In such chaos, could solar activity have influenced 3 Atlas? Possibly. But the timing was off. The object's thrust began months later, steady and detached from flare events. Radiation pressure fluctuates too little to explain the effect. Solar wind forces are thousands of times too weak. Unless the object had extraordinary material properties, high conductivity, extreme charge, or reflective efficiency, solar events alone cannot account for its behavior. Still, Burns's big wave theory persisted. Earth, the Sun, and this object all showing heightened energy at once. Maybe the connection wasn't direct, but environmental. Our solar system moving through a denser interstellar region, a zone of increased particle flux, influencing both planetary fields and passing visitors. The science was speculative, but the timing kept scientists uneasy. Inside laboratories, the mystery deepened. In 2025, Japan's Hayabusa 2 mission revealed new results from asteroid Ryugu samples. The tiny grains behaved strangely under simulated sunlight, releasing gases without visible vents, like a slow leak from a porous sponge. It was outgassing without a coma. Diffuse, invisible thrust. On a large scale, that kind of process could produce steady acceleration without optical signs. This discovery bridged the gap between comets and asteroids. A body could appear inert, yet still breathe gas invisibly, changing its motion. 3 Atlas might be doing exactly that, venting faintly through a porous surface, gases too pure or too fine to detect. It explained the smooth thrust but not the perfect zero in the third axis. The geometry remained too precise. Other missions supported this view. NASA's OSIRIS-RX had seen particle ejections from Bennu without visible jets. ESA's Comet interceptor simulations showed that microjets, unseen from Earth, could generate measurable acceleration if aligned by rotation. Suddenly, invisible venting wasn't fantasy. It was measurable physics. Yet even these new models had to thread an impossible needle, natural, but unnaturally perfect. Beyond the physics, human tensions emerged. Data was scattered across observatories, some private, some public. Astrometric fits varied. Debates moved from peer-reviewed journals to forums and social media. Some argued for conservative models. Others warned that dismissing anomalies too early risked missing something historic. Amid the noise, one fact stayed constant: 3 Atlas's movement was real. not an artifact, not a miscalculation, a persistent, measurable acceleration, confined to one plane. Artificial explanations lingered at the edge. A light sail matched every visible clue: flat thrust, no coma, steady brightness. If so, who made it? A relic of some ancient civilization, drifting for millennia? A probe? A fragment of alien debris? Or a natural wafer of ice and dust behaving like a sail by coincidence? Exotic physics hovered in the background. Some theorists pointed to dark matter streams, others to modified gravity, heliospheric boundary effects, or interstellar plasma currents. Each demanded new forces that no experiment had yet confirmed. To work, such mechanisms would need to produce measurable thrusts without violating everything we know about planetary motion, a tightrope few models could walk. Still, science keeps the door open. Every breakthrough begins as an anomaly that refuses to vanish. Mercury's orbit once defied Newton until Einstein's equations replaced him. Perhaps one day 3 Atlas will mark a similar shift or prove nothing more than a misunderstood rock. For now, the only truth is uncertainty. What happens next depends on observation. As it moves farther from the Sun, new data will refine its orbit. If the out-of-plane component stays zero, the mystery hardens. If a coma appears, the natural case wins. The James Webb Telescope may catch traces of carbon monoxide or faint heat emissions. Ground telescopes will test its reflectivity. AI will sift through past sky images searching for earlier sightings, maybe revealing when the acceleration began. The possibilities branch. If new data shows venting, the case closes an exotic but natural interstellar comet. If measurements reveal high reflectivity and low mass, the sail hypothesis rises. If nothing changes, if it fades quietly into deep space still accelerating, then the mystery remains unsolved. Each outcome teaches something different. A natural explanation reminds us that nature's variety is wider than our expectations. An artificial one reshapes our idea of life and intelligence across the stars. An unresolved one keeps science humble, forcing us to improve our tools and question our limits. 3 Atlas may never reveal its source, but it has already achieved something else. It has reminded scientists and everyone watching how fragile our assumptions are. The cosmos still holds surprises. Some bright, some silent, some gliding through space with invisible purpose. Somewhere, 3 Atlas continues to move. A dim point against the stars, accelerating in perfect silence, its motion written in equations that don't yet balance. And somewhere here, on the small world that noticed, we watch. Waiting for data, for answers, for the next anomaly that forces us to ask again what is natural, what is possible, and what else is out there, moving through the dark with purpose unknown. The night sky is full of motion. Planets drift, comets flare, and debris from ancient collisions whispers across the void. Most of it follows rules so clean that even chaos looks ordered. But once in a while, something steps out of line. 3 Atlas is that something. It came from outside the solar system, a messenger from another star. When it was first tracked, astronomers expected a cold lump of ice and dust on a routine hyperbolic arc, bound only by gravity. But within weeks, the data broke the model. The object was not falling as it should. It was accelerating. At first, they suspected instrument error. Then a processing glitch. But every recalculation said the same thing: the numbers didn't lie. 3 Atlas was speeding up, steadily, smoothly, without a cause anyone could see. In Pasadena, the JPL computers mapped its motion again. A 1 radial. A 2 tangential. A 3 vertical. The out-of-plane component that should always exist in natural venting was gone. 0. The software flagged it again and again, and still it held. The thrust lived only in the plane of the orbit, as if confined by intention. Telescopes turned toward the coordinates. No tail. No haze. No flicker of dust or gas. The light stayed constant, sharp as a star. Even when it passed closer to the sun, when an ordinary comet would roar awake, 3 Atlas remained silent. In those weeks, the sun was angry. Flares lashed out, magnetic storms battered satellites, auroras reached southern Europe. On the ground, instruments trembled from geomagnetic surges. Burns, the geophysicist tracking Earth's field, warned that a wave of energy was washing through the system. At that same moment, 3 Atlas began to move faster. Coincidence? Perhaps. But the timing unsettled even the skeptics. Space agencies compared notes. Data from the Minor Planet Center confirmed the acceleration. Observatories in Chile, Hawaii, and Japan cross-checked the light curves. No coma. No jets. The object behaved like a perfect stone, and yet it moved as if pushed. Imagine standing beside a frozen lake. You drop a stick on the ice and watch it slide, slowing down until friction stops it. Now imagine that same stick sliding faster and faster, with no hand touching it, no wind, no sound. That was the riddle facing astronomers. The first explanations clung to normal physics. Maybe uniform venting, thousands of tiny gas leaks evenly distributed across the surface, produced the net thrust. Maybe carbon monoxide jets fired invisibly, too faint for detection. Maybe micro-outgassing or photophoretic forces from sunlight. Each theory explained one piece but broke another. None accounted for the perfect planar control. None explained why the object's brightness refused to change. When ordinary physics failed, minds turned to the extraordinary. A sail, thin and reflective, pushed by sunlight. Radiation pressure at 1 astronomical unit exerts a tiny but steady force, enough to move a feather-light structure. A sheet of material a few micrometers thick could gain exactly the measured acceleration. The absence of outgassing made sense. The flat thrust made sense. Everything about the data fit the sail. Everything except one thing: nature does not build sails. If it was artificial, whose was it? A fragment of a probe launched eons ago? Debris from a civilization that vanished before Earth cooled? A beacon? Or a coincidence born of natural symmetry too rare to repeat? The idea split the community. The cautious majority favored natural explanations stretched to their limits. The minority argued that the simplest model, constant thrust in one plane, no mass loss, no tail, was indistinguishable from controlled propulsion. Meanwhile, other anomalies surfaced. Oumuamua in 2017 had shown a similar acceleration, also without a coma. Borisov in 2019 had looked perfectly natural. Now 3 Atlas seemed to sit between them, blending traits of both. 3 visitors from interstellar space in less than a decade, each stranger than the last. If that rate continued, perhaps the cosmos was full of them, crossing solar systems unseen until one passed close enough to notice. While the debates raged, the sun climbed toward maximum activity. Flares multiplied. On March 19, an X-3.7 class flare erupted, followed by a coronal mass ejection that slammed into Earth and shook its magnetosphere. The auroras reached the Mediterranean that night. Some wondered whether such storms could influence interstellar bodies, charging them, twisting magnetic fields, nudging trajectories. The forces were small, but if 3 Atlas carried charge or metallic inclusions, they might not be negligible. Still, the acceleration persisted even after solar conditions calmed. Whatever was driving it seemed internal, not environmental. Then, in Japan, scientists studying samples from asteroid Ryugu found something new. When they warmed the grains under simulated sunlight, the dust began to breathe. Trapped gases leaked slowly through microscopic pores, producing steady thrust without visible venting. A process so gentle it left no coma, no flare, only motion. Suddenly, invisible venting no longer sounded impossible. Maybe 3 Atlas wasn't a sail or a probe at all. Maybe it was porous, leaking vapor too faint for telescopes to see. But again, the geometry problem remained. Even diffuse outgassing should wobble as the object rotates. Only a body aligned perfectly with its orbital plane could maintain a zero out-of-plane component. A coincidence too sharp to ignore. Data from NASA's OSIRIS-RX mission to Bennu echoed the same theme. Dust lifted spontaneously from its surface, not from vents, but from static discharge and microfractures. The physics of small bodies was turning out to be richer than expected. 3 Atlas might simply be the latest revelation, nature behaving like technology. Behind the science, human drama unfolded. Forums filled with leaked astrometric fits. Independent analysts published and reviewed models. Some insisted the data had been tampered with, others accused the fringe of sensationalism. The truth sat buried under speculation. Amid the noise, the AI systems of the Vera Rubin Observatory began scanning sky survey archives. Algorithms trained to spot orbital deviations flagged other faint movers, some explained, others not. Perhaps the universe was full of small anomalies we had never seen before. Perhaps 3 Atlas was only the first to catch our attention. In conference halls, the tone shifted. A few researchers admitted that calling it just a comet no longer satisfied the equations. Papers proposed hybrid models, porous venting assisted by radiation pressure, sublimation of exotic ices coupled with rotational alignment, invisible plasma interactions. Each tried to preserve the natural while acknowledging the unnatural precision. Outside academia, the story spread through public channels. To some it was proof of life beyond Earth. To others, another overhyped mystery that would fade with time. But every night, telescopes tracked it, logging data point by data point, the silent acceleration continuing. Months passed. By early 2026, 3 Atlas began drifting outward again, dimming but still measurable. No flare-ups, no fragmentation, no deviation from its new velocity. It moved as if a command had been completed. Scientists listed what was known. Interstellar origin confirmed. Sustained non-gravitational acceleration for 20 days. Zero measurable out-of-plane thrust. No coma, no jets, no brightness change. Possible size between tens and hundreds of meters depending on reflectivity. And what was unknown, everything else. Mass composition. Spin. Shape. Purpose. Theories branched into 3 paths. 1. An extraordinary natural object, its symmetry and composition conspiring to mimic control. 2. An engineered sail or probe, evidence of intelligence predating us. 3. A phenomenon revealing physics we haven't yet written down. Each path held consequences too large to ignore. The first redefined cometary science. The second redefined civilization. The third redefined reality. Observatories prepared their final campaigns before the object slipped beyond reach. The James Webb Telescope aimed its infrared instruments, searching for heat or faint emissions. The Keck telescopes scanned for spectral lines of carbon monoxide and nitrogen. AI sifted the noise, pushing detection to the limit. If even a trace of gas appeared, the natural case would prevail. If not, the mystery would deepen. Meanwhile, theorists explored extremes. Some modeled thin reflective ices forming in interstellar voids, natural sails born from shattered planetary crusts. Others simulated dark matter drag and failed to reach the necessary magnitudes by orders of magnitude. A few speculated that the heliopause, the edge of the sun's influence, might impart magnetic charges to bodies crossing it, causing electromagnetic thrust once they re-entered the solar wind. None of the models fit perfectly. As the debate stretched on, one truth settled in: anomalies drive science. Every revolution begins as a contradiction. Mercury's orbit once broke Newton's equations. The missing mass of galaxies birthed dark matter. The accelerating universe revealed dark energy. Perhaps 3 Atlas is another of those quiet beginnings, a question too strange to answer until technology catches up. If it fades into deep space without resolution, its legacy remains. It forces us to look closer, to design better instruments, to keep an open mind. Somewhere out there, others like it may pass unseen, drifting between stars, carrying fragments of history or physics we have yet to recognize. For now, it moves on, no beacon, no roar, no trail, only a faint point sliding through the dark, defying prediction. Astronomers watch its coordinates shrink on their screens, the last data packets arriving from telescopes before the signal dips below detection. When future observers read the records, they'll see the same line of code repeated: A3 equals 0. No vertical thrust. Perfect planar motion. A signature that looks less like nature, more like intention. And so the question lingers in the silence it leaves behind. Was 3 Atlas a comet, a sail, a probe, or a message? No one knows. But its trajectory remains etched into the archives, a scar in our models of the solar system, reminding us that even in the age of precision and reason, the universe still keeps secrets. It accelerates into darkness. We follow with our eyes, our equations, and our doubt. And we wait for the next visitor. In the years that follow, the data from 3 Atlas becomes a kind of gravitational center for curiosity. Every astrophysicist, planetary scientist, and graduate student with access to a computing cluster runs their own simulations. They start with Newton, layer in radiation pressure, add venting models, dust drag, plasma flow, Lorentz forces. They tweak parameters until the orbit fits, then the residuals rise again, stubborn and silent, like a reminder that something is missing. Each failure adds weight to the mystery. In observatories from Chile to the Canary Islands, nights are booked for target T3A. Technicians calibrate instruments to the faint magnitude of 14.8, trying to tease out a whisper of a coma or flicker of color shift. Nothing. The light is pure reflected sunlight, cold and constant. At JPL, analysts argue over measurement errors. If we're wrong about the geometry, A3 might not be 0, one says. Another answers, we're not wrong. The error bar's close like a vice. The 0 holds. The silence that follows is heavier than excitement, it's the sound of disbelief that won't die. On forums, the public debate mirrors the scientific one. Some call it proof of alien design. Others call it noise from overfit models. Between them sits a smaller group who say the question is larger than both. Maybe we still don't understand how matter behaves when it's born from other stars. New missions rise in response. The Comet Interceptor program extends its scope, preparing not only for comets but for anything interstellar. The proposal includes microprobes with self-deploying sails, irony layered on irony, to chase future visitors before they vanish. AI systems, trained on millions of sky images, keep scanning. They find 2 faint trails from 2023 that might belong to an earlier passage of 3 Atlas. If confirmed, the pre-covery extends its timeline and shifts the start of the acceleration back by weeks. The pattern deepens. It began to accelerate far from the Sun, in regions too cold for sublimation. That discovery turns even the skeptics quiet. Meanwhile, Earth's own magnetosphere records a steady rhythm of storms. Burns continues to warn that the solar system is moving through a dense patch of plasma. Few take him seriously, but his plots of solar wind density show repeating peaks. The same rhythm appears in the timestamps of 3 Atlas's strongest acceleration. coincidence, or a coupling between the heliosphere and the object's surface? The papers stay cautious, but whispers of energetic coherence start to circulate. By mid-2026, the object has faded beyond most telescopes. Only the largest mirrors can still catch its glint. Its distance makes real-time study impossible, but the data keeps feeding into models. A team at the Max Planck Institute runs simulations of porous, nitrogen-rich bodies exposed to sunlight in the inner system. Their models show diffusive gas release through microfractures can produce smooth thrust if the rotation axis aligns within 2 degrees of the orbital plane. The odds of that happening by chance, 1 in 10,000. Not impossible, but rare enough to keep doubts alive. At Harvard, a smaller group revisits the light sail theory. They calculate that a reflective sheet 200 meters wide, a few atoms thick, made of carbon-silicon composite, would produce exactly the observed acceleration under solar radiation. Its density would be less than air, its mass a few tons at most. Natural formation? None known. Engineered? Perhaps, if someone somewhere once learned to launch wafers between stars. The paper is careful, mathematical, devoid of sensationalism. But the implication spreads faster than peer review. Headlines call it the second Oumuamua. Podcasts and documentaries declare the sail hypothesis reborn. NASA responds with restraint, data inconclusive. Further observation required. By the time the debates cool, 3 Atlas is gone, beyond the reach of radar, beyond the light of our largest mirrors. But it leaves behind more than questions. It leaves an era. Funding for small body missions triples. New software pipelines are written to flag any deviation from Keplerian motion in real time. The next interstellar object won't escape so easily. In 2027, a faint point appears again in survey data. The algorithm flags it: high velocity, hyperbolic orbit, slight non-gravitational acceleration. The name comes automatically, 4 Erebus. When the first orbital solution is released, scientists notice something uncanny. It's a 3-component isn't 0, but nearly so. The same pattern, fainter but familiar. 3 Atlas was not alone. For the next decade, these visitors keep coming. Some behave like comets, some like stones, a few like sails. None match perfectly. Each adds a fragment to a mosaic we still don't know how to read. And in every dataset, the same uneasy thought grows. Maybe interstellar space is seeded with the remnants of civilizations long extinct, thin sails, broken probes, forgotten messengers drifting through the dark. Or maybe nature, left long enough, learns to imitate design. Theories multiply. Some physicists propose that radiation pressure sculpts ultra-thin ices into reflective sheets near dying stars. Others think the heliosphere itself shapes dust into self-organizing membranes. A few whisper about life, not biological but mechanical, spreading like spores. None have proof. Meanwhile, the AI systems learn faster than humans can review. By 2030, machine analysis dominates sky surveys. They find anomalies in every direction, objects accelerating, decelerating, wobbling in ways gravity can't explain. The catalogue of unmodeled movers passes 100. One by one, telescopes confirm them. Some show comas when seen up close. Others remain silent and clean. Patterns emerge: the planar thrust, the smooth brightness, the absence of dust. Whatever 3 Atlas was, it wasn't an accident. In 2032, ESA launches a small interceptor, an autonomous probe designed to rendezvous with the next fast visitor. It rides a solar sail of its own, a mirror grown from lessons learned from the mystery. Irony again, we build what we once could not explain. When the next object arrives, the probe will meet it. Maybe it will find a rock. Maybe a wafer. Maybe something we don't have a word for. And somewhere far beyond Pluto's orbit, 3 Atlas continues its silent burn. Its speed now carries it beyond the sun's pull, out toward interstellar night. No signal, no reflection stronger than background noise. Only motion, steady, exact, defiant. If it was a machine, its purpose is unknown. If it was natural, its precision is miraculous. Either way, it has already changed us. Because after 3 Atlas, no astronomer looks at the sky the same way. Every new light is suspect. Every deviation is a question. Every orbit might hide intent. The story doesn't end with an answer. It ends with a shift in perception. A realization that the boundary between physics and possibility is thinner than we thought. The stars have always sent visitors. We simply lacked the eyes to notice. Now that we do, the universe feels closer, stranger, and infinitely more alive. Somewhere out there, 3 Atlas keeps its course, its engines, if they exist, quiet as thought. And on Earth, beneath the same silent gravity, we wait for the next spark in the darkness.